Chapter 4 deals with looping through lists, creating sequential lists, creating numeric lists. Basically, we can generate a list of numbers, uh, what a tuple is, and how that differs from a traditional list. And then we will review some styling rules for Python. In Python, there are two types of loops. There's a for loop and a while loop. And as a little review for those of you that are familiar with coding languages, the while loop in Python is very similar to other languages. It starts with the keyword while. There is some type of variable that you are testing, and as long as the variable you're testing is less than a particular value, you're going to stay in the loop. The most important thing is in this loop is that at the bottom of the loop, you change that variable that is being tested. So it may be just a counter that you're incrementing, and you're going to stay in the loop as long as the counter is less than a certain value. Or the variable that you're testing may be something that the user has to key in. For example, if they don't want to continue, they can type a Q to quit. But the key here is that at the bottom of the loop, you need to input or change the variable you're testing. Okay, and you'll notice above the loop that we initialize that variable that we're testing. And that's pretty much how you set up a while loop. Now remember, in Python, we do not use curly braces. So the way that it knows what commands are executed in the while loop is it looks for the indentation. So that indentation is extremely important, and it's very picky about the number of spaces. So if you indent the first statement 5 spaces, you need to do them all 5 spaces. Okay, so you just have to be very consistent with that. The example I have here is just a very simple numeric counter where we set the counter to 1 and we stay in the loop while the counter is less than 10. Okay, and you'll notice that there is a colon at the end of the while statement. That is a little different than other languages. And then we've got our statements indented. So to see what this looks like, we can go ahead and run it. Okay, and so you can see that it went through that loop 9 times. Now, what if we wanted it to go through the loop 10 times? Well, then instead of doing less than 10, we should have done less than or equal to 10. Whoop. Let's get an equal sign in there. And then it would go through 10 times. Okay, so that's another thing you need to be aware of when you're dealing with loops. If you begin with a 1 and you want it to go through a specific number of times, then it's going to be less than or equal. Now we're going to be working with while loops when we get into chapter 7, because that is where we are going to be discussing input, user input. In this particular chapter, we specifically work with for loops. For loops in Python are a little different than other languages. the way we set them up is we still use the keyword for. Then you have to enter a variable that you want to represent each item in the list. So for this, I just put item, okay? And then you have the keyword in, and then it's whatever you named your list and a colon. This is kind of like a for each statement in other languages. Right below your for statement, indented, are the statements that you want executed while you're in the loop. I have a little example here. So I have a list of zoo animals, and I've got for animal in zoo animals. So animal, as it is looping through, animal is going to represent each element in my list. So when we do a print animal, the first time through, it's going to print tiger. Okay, then animal is going to take on the value of lion, so it'll print lion. Then it'll take on the value of rhino, so it's going to print rhino. And you can see what the output looks like here. If you wanted to, you could do a little fancier output, like example 2. Example 2 is using an F string. So we've got our counter that we're going to print out. And then we've got a little F string where we are capitalizing the first letter. And you can see we have a counter up here. And then we add 1 to it each time so that we get numbers next to our animals. And we can copy and paste this. And you can see how that output looks. Now, one thing that is interesting in Python is that if you want to increment something by 1, you either need to do it like this, which is pretty common in every language. Instead of saying counter equals counter plus 1, you can do counter plus equal 1. That works fine. And this also works. Either one of those is going to work. Let me clear the screen here. Okay, so both those techniques work fine. What does not work is counter plus plus. So for those of you that are used to using that increment and decrement operator, the plus plus or the minus minus, that does not work. Let me show you. You get an error. Okay, so that will not work in Python. What most coders would do is plus equal, just because that is shorter. We've already talked about how important indentation is. And it is super picky about the indentation. So if I didn't indent my counter the same, it has a problem. Right? It's super picky. Within a block, they have to be indented the exact same. So you need to be consistent with this. And looking at this example, what do you think would happen if we ran the program and it looked just like that? Well, we have nothing indented. And in a loop, you have to have at least one line indented. So what we would get is an error. And then what do you think would happen in this program? We would not get an error. What would end up happening is it would still go through each animal, but the counter would say 1 for every single animal. And let me show you how that looks. That's just a matter of moving this over here. And why did that happen? Because counter is not part of the loop. It is not indented. So it's going to do the loop just with this one line. And then when it's done, it comes down and increments the counter, which is pretty pointless at that point in time. In Python, the only time you should indent is if something is part of a block. Otherwise, you should not indent. In fact, you'll get errors if you indent and it's not an appropriate time to indent. As far as the length of your lines go, there is differing opinions on how long a line of code should be. Initially, Python developers wanted a maximum of 80 characters per line. That is what most people go with. And unless there is a reason to deviate from that, I would try to stick with the 80 character rule. It's not like it's going to give you a syntax error if you go over 80 characters, okay, but that's just kind of standard practice. As far as blank lines go, you will add blank lines for readability. I personally use them to separate logical groups within my code. And that is also a standard practice. Now, the hands-on videos are separate from the lecture, so I'm going to skip over that. And we're going to talk a little bit more about numbers and functions that you can use with numbers. And one of the neatest functions is range. What range does is it will generate a list of numbers for you. If you give it a beginning number and an end number, it will generate numbers in that range. If you don't give it a beginning number, if you just give it an ending number, it starts with 0. And the range function also lets you indicate a step. And you'll notice that these parameters are separated with commas. And let's play with this a little bit. And if you are going to use range, then when you create your list, you are going to use the list constructor. Inside the list constructor is where you give it the range and it generates everything for you. And so this is going to start with 1 and it's actually going to end at 50. So that's kind of a little quirk. The ending here is 1 less than what you have indicated. And so that you can see this on my screen, I will change this to 11. Okay, so you can see even though I have the ending number at 11, it stopped at 10. Okay, so that is something that you're going to have to remember. Now, it also lets you specify a step. So if I do that, it's going to do every other number. And that's giving me odd numbers. What if I wanted even numbers? Well, I would start with 2, and I would probably tell it, yeah, ending at 11 is fine. Okay, because that stops at 10. Okay, so we've got the beginning number the ending number, or I should say one larger than the ending number, and the step that you want to increment by. Another thing that you can use with numbers is statistical functions. And for those of you that are familiar with spreadsheets, the same statistical functions are in Python. Python is used for data analytics. And so there are a lot of math functions available in Python. So we're going to take a look at just a couple of the more popular statistical functions. And let me copy this. So what this is doing is it's generating a list of numbers, and it happens to be even numbers. And then it's going to print the largest number using max, and it's passing it the entire list. Then it's going to retrieve the smallest number using min, and then it's going to total all the numbers. To find the average, we actually are doing a calculation. We're taking the sum of all the numbers, and then we are taking the length of our list. Okay, and we're dividing it by the number of items in the list, and that is going to give us our average. And when I run this, the results should look similar unless I make a little change here. Why don't we do 101 for our ending, and we'll go up every fifth, and we'll start at 1. So if we go up our step is every fifth, the largest is 96, the smallest is 1. Here's our total. Then we have the average. In Python, there is an advanced feature called list comprehension, and it offers shorter syntax when creating a new list that is based on values in an existing list. And it does offer an advantage of allowing you to check what's in the list before you add it to the new list. So it lets you check a condition. First, we're going to look at the list comprehension syntax in its simplest form, and then we'll take a look at that same syntax with a condition added in. In the book, they give you this little example, and this does not use list comprehension. Okay, so we have a list called squares. It's created, it is empty. And then you can see that we have a for loop, and it is looping through the numbers in this range. And we're calculating a value for square. And then we are appending that value to the squares list. And then after it gets done with the loop, it prints the entire list. There is a way to code this that involves a lot less lines, and that method uses list comprehension. And let's see. So we're going to end up replacing the first 4 lines. I'm going to comment these out. Using list comprehension, we can replace 4 lines with a single line of code. So for our squares list, we are going to have the value times 2, or raised to the second, for the value that is in the range 1 through 11. And that is how it's going to populate squares. So it's doing the same thing as this for loop, it's just doing it in one statement. So the value raised to the second is going to be used for whatever number is in the range. So it's going to start with number 1, so it's going to add 1 raised to the second. Then it's going to go on to number 2. It's got 2 raised to the second. It goes down to number 3. It stores 3 raised to the second. Number 4 stores 4 raised to the second, and so on. If you can remember this syntax, it is way shorter than the 4 lines above. And here is another example. Now, what if we add a condition? Let's say we have a list and we don't want every single item in the list copied. Okay, so we have, in this example, we have a list of courses, but we only want to add the CIT courses to our new list. If we do not use list comprehension, okay, so the long method is using a for, so for course in courses. So course is our variable that's going to be storing each one of the classes. We're going to check to see if CIT is in course. So is CIT in CIT 228? Yes. Okay. If it is, if that's true, then it appends to the CIT list. If it's false, it just goes up and grabs the next course. And then it says, is CIT in the course? Yes, it is. It appends it, goes back, grabs the next course. Is CIT in that course? Nope. Goes back up, grabs the next one. Is CIT in that one? Nope. Grabs the next one. Is CIT in that one? Nope. And then it prints out. Okay, and you can see that's exactly what it did. Now, using list comprehension, we could really shorten this up. In fact, we can get rid of the entire for loop. And we can change this. Now, I could say course for course in courses, or I can abbreviate it C, stands for course, C for C, course in courses. Courses refers to my list. Now, if I just left it like this, CIT courses would contain all of them. But I don't want all of them included. What I want to do is check to see if CIT in C. So as it goes through and it grabs each one, is CIT in that? If it is, add it. Okay, so it grabs the next one. Is CIT in that? Yes, add it. CIT in this one? No, so it does not get added. So this variable can be course, it can be courses, it could be class. Oop. But it represents that element in the list that you are currently processing. Let's see. So class is not a good, it's a reserved word. So we'll go back to C. C, course, item, any of those are okay. Don't use a reserved word. Okay, I could change it to item. That would work too. Okay, but you just can't use a reserved word. Now, moving forward here, going to talk a little bit more about working with lists. There is something called slicing, where you basically can select a range within the list. So let's say you don't want the whole list, you want to print out the list starting at a certain point and ending at a certain point. Instead of just including the name of the list, in brackets, you can give it the starting subscript, a colon, and the ending subscript. And that is all it will retrieve. And we'll copy this one. And remember, the first one has a subscript of 0. So we've got 0, 1, 2, and we asked for 2 through 4. So 2, 3, and 4. Now remember, it does 1 less. So what we end up getting is 2 and 3. Okay, so that's kind of quirky. If we wanted the last course included, we would have to change that to 5. 0, 1, 2, 3, and 4. Okay, because it basically subtracts 1 from that ending number. Now, what if you want it to start at 0? And you want all of them printed? Well, then I probably wouldn't subscript in, but using this technique, if you leave the first number empty, it starts at 0. Okay, if I wanted it to start or stop, only print out 0 and 1, I can have it stop at 2. Okay, that is called slicing. You can use that slice operator to copy. And what it will do is copy everything. And so we've got courses. We'll change this a little bit. Actually, I'll just copy this. So we got my courses, we have your courses, which I copied everything in my courses, and then I appended. So I added a couple courses to your courses. I added some courses to my courses, sorted them, and then I printed them. We're going to go ahead and run this. And you can see that the list, both the lists include the 228, 195, and the Math 120. Okay, they are right here and right here. And then they have the additional courses. Now, you may be thinking, well, what if I want only the first two copied? Does that slicing technique work? Yes, it does. So if I only want 0 and 1 copied, I can leave the start number blank and do my end number at 2. Okay, and then I would only have those 2 CITs copied. What if I only want Math 120? 0, 1, 2. And we'll see, I have not tried to do this. If we start at 2 and we end at 3, because it subtracts 1, remember, that should just give us math. Let's see if that works. Yep. Okay, so you can use that slice operator to copy, and you can give it beginning and ending numbers if you want. Copying using the slice operator will keep the lists separate. And you could see that when I added to one list, it did not add to both. If you try copying without using the slice operator, the lists use the same area of memory, so they basically become an alias for each other, and they are not separate. So if I do this, whoop, and I do not use the slice operator, these lists are referring to the same place in memory. So anything that I do to the my course list is going to affect the your course list and vice versa. And you can see that when I run it. They are identical lists because they are in the same area of memory. So if you truly want to copy something, then make sure you use the slice operator. That is really important. And moving on, tuples. So a tuple is basically a list that has values you cannot change. So it's immutable, it's unchangeable. And to create one, instead of using the brackets, you use parentheses. Okay, and that's the total difference between doing a tuple and a list, okay, as far as creating it goes. The standard practice to use parentheses, however, I should mention that if you do something like this with a comma, it is going to assume it's a tuple, even though you didn't put it in parentheses. I would always put it in the parentheses just because that is standard practice. That is how most people do it. Anybody reading your code would know exactly what it is. If you only have one value in the tuple, you still have to put the comma in. which is a little weird also, but it's that comma that is signifying it's a tuple. So that is kind of a key factor when you create them. In this little example, I have a lone period list. It is a tuple, which means this is not going to change. So the only time that you are going to create one of these is if you have values that you know won't change or that don't change often, like interest rates or loan periods, that type of thing. You can still interact with that list the same way that we've interacted with a normal list. So we can do for loops, we can do if statements, we can subscript in. The only difference is we can't change the values. So if we do something like this, okay, you can see that we can still access everything that's in that list. And if we wanted to, we can subscript into the list. What it's not going to let us do is something like this. It will not let you change the list. So if we wanted to change that first element to a 1, it is not going to let us do that. Now you can see it's telling you that you cannot do item assignment in a tuple. So what do you do if you want to change the list? Well, what it will let you do is reassign the variable. Remember, it's a loosely typed language. So if we want to change the list, we have to change the loan periods variable. Okay, if we do something like this, it will allow it. It just doesn't allow you to subscript in and change an element. It would not let you use the pop method. It would not let you use the append method, okay? Because those all involve changing single elements, but it will let you reassign that variable. And at this point, we are done covering information from Chapter 4. And you are ready for your hands-on exercises.